Hi guys, my name is Melissa, and in today's video we're going to be talking about divisibility. And so, it's common sense that all numbers are divisible by 1 because any number divided by 1 is basically going to give itself. And we all know that even numbers are divisible by 2 because, for example, all even numbers, 2, 4, 6, 8, as well as larger numbers that are even numbers like 10,000 or 10,502. If they're even numbers, all are divisible by 2, and we can recognize that these are even numbers because the last digit in the ones place is always going to be an even number like 0, 2, 4, 6, or 8. Then we also have divisibility rules for other numbers as well. And so how do we know if numbers are divisible by 3, 7, or 11? And so we'll talk about multiple divisibility rules and go over some practice problems. And so for 3 and 9, if a number is divisible by 3 and 9, then that means that the sum of all its digits can be divided by 3 and 9. And so what that tells us is that if we have a number, and for example, if we have the number 135, we take the sum of the digits, and that is 9. So since 9 can be divided by 3 and 9, we know that 9 is a multiple. We know that 9 is divisible by 3 and 9. And so since 9 is a multiple of 3, if we have a number that is divisible by 9, then that means that the number is automatically divisible by 3. So for example, for 135, since the sum is divisible by 9, we know that the number 135 is going to be divisible by 9. But also, since the sum 9 is divisible by 3 as well, since 9 is a multiple of 3, we know that 135 is also divisible by 3. But then, when a number is divisible by 3, that doesn't always mean that it's divisible by 9. And so we know that when a number is divisible by 9, it's always divisible by 3, but it's not the same the other way around. Because, for example, if we have a number like 15, 1 plus 5 is equal to 6. So 6 is divisible by 3, and so 15 is divisible by 3, but 6 is not divisible by 9, and so that is the difference. And so we'll look at some example problems. So for the number 312, 3 plus 1 plus 2 is equal to 6. And so 6 is divisible by 3, so the number is divisible by 3. But it's not divisible by 9, so it's not going to be divisible by 9. Let's take a look at 443. So 4 plus 4 plus 3 is going to give us 11, and 11 is neither divisible by 3 nor 9, so the number 444 is not divisible by 9 nor 3. And if we take a look at 567, the sum of the digits are going to be 18. So 18 is divisible by both 9 and 3, and so the number 567 is divisible by both 3 and 9. And if we look at 818, the sum of the digits are going to be 17. And 17 is neither divisible by 3 nor 9, so the number 818 is neither going to be divisible by 3 or 9. And so now we're going to talk about divisibility by 4 and by 25. So if the last two digits of a number can be divided by 4, the number is divisible by 4. And divisibility by 25 is also based on the same rule. So for example, if we have the number 424, then we're going to look at the last two digits. So we're going to look at 24. And 24 is divisible by 4 because 24 divided by 4 is going to be 6. And so that tells us that 424 is going to be divisible by 4. Now, the same rule also applies to 25. So if we have the number 175, we're going to look at the last two digits. So the last two digits are going to be 75. And since 75 is divisible by 25, since 75 divided by 25 is going to be 3, we know that 175 is divisible by 25, just by looking at the last two digits. And so we're going to go over some example problems. So the second example, or this example, states that we should test the following numbers for divisibility by 4. And so, for example, we have the number 1016. If we look at the last two digits, we have 16, and 16 is divisible by 4 because 16 divided by 4 gives us 4. And that tells us that this number is divisible by 4. Now for 3234, if we look at the last two digits, we have 34, and 34 is not divisible by 4, and so the number is not divisible by 4. And if we have the number 2348, we're going to look at the last two digits, 48, and 48 is divisible by 4 because 48 divided by 4 is equal to 12. And so this tells us that the number 2348 is divisible by 4. Now if we look at 1558, the last two digits are 58, and 58 is not divisible by 4, so the number would not be divisible by 4. Now let's move on to the next page. Now we're going to test divisibility for 25. And again, we're looking at the last two digits for 25 as well. So for 1025, the last two digits are 25. So 25 is divisible by 25 because it's just dividing by itself. So that's going to be 1. And so it is divisible by 25. Now if we look at 2235, the last two digits are 35. And 35 is not divisible by 25, which tells us that the number 2235 is not divisible by 25. For 3175, the last two digits, 75, is divisible by 25, and so the number is divisible by 25. For 4445, the last two digits, 45, is not divisible by 25, so the number 4445 is not divisible by 25. Now we're going to look at divisibility by 8 and by 125. So for 8 and 125, we're going to look at the last three digits. So if the last three digits are divisible by 8, the number is going to be divisible by 8. And it's also the same rule looking at the last three digits for 125 as well. So for 13,125, we look at the last three digits and we have 125. So it's going to be dividing by itself. So since 125 is divisible by 125, we're going to say that this number, 13,125, is divisible by 125. But then for 8, 125 is not divisible by 8 because it gives us a remainder. So since 125 is not divisible by 8, 13,125 is not divisible by 8. For 132,000, we have 0, 0, 0. And so if we have zeros, then it's basically divisible by both 8 and 125. So we're going to say it's divisible by 8 and by 125 because the last three digits is divisible by both numbers. For 52,450, the last three digits are going to be 450. And so 450 is not divisible by 8 or 125. So we're going to say that 52,450 is neither divisible by 8 nor 125. For 12,400, the last three digits, 400, is not divisible by 125, but it is divisible by 8 because 400 divided by 8 gives us 50. So 12,400 is only divisible by 8, so it's saying that it's not divisible by 125. Now we're going to talk about divisibility by 7 and by 13. And so if the difference of the last three digits of a number and all its preceding digits can be divided by 7 or 13, the number is divisible by 7 or by 13. So this is a little confusing because it has a lot of steps involved. But for example, if we have 2,100, then we're going to look at the last three digits, which is 100. And the preceding digit, or the preceding number, is going to be just 2. And so the difference is going to be 98. And 98 is divisible by 7 because 98 divided by 7 is going to be 14. And for 13, we're going to see if 98 is divisible by 13, and 98 is not divisible by 13, so we're going to say not divisible by 13. So basically that is how you solve for whether a number is divisible by 7 or 13. So you look at the last three digits and compare the difference with the last three digit and any preceding numbers. So we'll do some more practice using example problems. And so we have example 5 to check whether numbers are divisible by 7 or 13. And so for the first number we have 2,093. And so the last three digits are going to be 093, which basically is 93. Right, since we have a 0 in the beginning, that just tells us the number is 93. And the preceding number, preceding digits before the last three digits are going to be 2, So the difference is going to be 91. And so now we're going to test whether 91 is going to be divisible by 7 or 13. And 91 divided by 7 is going to give us 13. And 91 divided by 13 is going to give us 7. So that tells us that 2,093 is divisible by both 7 and 13. Now we're going to look at 4,095. So for 4,095, the last three digits are 095, which is again 95, and the preceding digit is just going to be 4. So the difference is going to be 91. Again, we're going to see if 91 is divisible by 7 or 13, and we saw in the previous example that 91 is divisible by 7 and 13. And so 4,095 is divisible by both 7 and 13. Now we're going to take a look at 16,042. So the last three digits are 042, which is just 42, and the preceding digits are going to be 16. So the difference between 42 and 16 is going to be 26. And so we're going to see if 26 is divisible by 7, and so it's not divisible. So 26 is not divisible by 7. But 26 divided by 13 gives us 2, so it is divisible by 2. It's divisible by 13. And so that tells us that 16,042 is divisible by 13, but not 7. And then we're going to see if 54,864 is divisible by 7 or 13. So the last 3 digits are going to be 864, and the preceding digits are going to be 54. And so the difference is going to be 810, and 810 is not divisible by 7 or by 13. And so that tells us that the number 54,864 is not divisible by 7 or by 13. Now we're going to talk about divisibility by 11. And so if the difference of the sum of the digits in the even place values and the sum of the digits in the odd place values is 0 or a multiple of 11, the number is divisible by 11. So the key points are that the difference of the sum of the digits in the even place and the sum of the digits in the odd place is 0 or a multiple of 11, then that tells us that the number is divisible by 11. So for example, if we have the number 135,795, we're first going to look for the sum of the digits in the even place. And so we have 3, 7, and 5, since it's going to be a second number, fourth number, and sixth number. So we're going to do 3 plus 7 plus 5, which is equal to 15. And the sum of the digits of the odd place, it's going to be 1 plus 5 plus 9. Since 1 is the first number, 5 is the third number, and so 9 is the fifth number. That's going to be 15. And the difference between these two sums are going to be 15 minus 15, which is 0. And when the difference is either 0 or a multiple of 11, the number is divisible by 11. So we know that 135,795 is divisible by 11. Now we'll take a look at 258,016. And so if we look at the number 258,016, the sum of the digits in the even place is going to be 5 plus 0 plus 6. And that is going to be 11. And the sum of the digits of the odd place is going to be 2 plus 8 plus 1. And so that is going to be 11. And so 11 minus 11 is going to be 0. So we know that this number is divisible by 11. Now we're going to take a look at the number 123,456. So for this number, the sum of the digits in the even place is going to be 2 plus 4 plus 6. And that is equal to 12. Now the sum of the digits of the odd place is going to be 1 plus 3 plus 5, which is equal to 9. And so the difference is going to be 3, and 3 is not 0 or a multiple of 11. So we know that 123,456 is not divisible by 11. Now let's take a look at 234,765. So the sum of the digits in the even place is going to be 3 plus 7 plus 5. That is going to be 15. And the sum of the digits of the odd place is going to be 2 plus 4 plus 6. That is equal to 12. So 15 minus 12 is going to be 3. And so again, since 3 is not 0 and it's not a multiple of 11, 234,765 is not divisible by 11. Now we're going to look at some example problems. And so example 7 says, if 45,067m is divisible by 3, find the possible values of m. So the number is 4567m. So we're looking for what possible numbers m could be. So there's 5 digits, and the rule for divisibility by 3 is that the sum of the digits must be divisible by 3. And so the sum is going to be 4 plus 5 plus 6 plus 7 plus m, and this must be divisible by 3 for the number to be divisible by 3. And so 4 plus 5 plus 6 plus 7 plus m is basically 22 plus m. And so, and m can only be numbers 0 to 9 since it's one digit. And so we're going to look for multiples of 3 that are greater than 22. So multiples of 3 that are greater than 22 are going to be 24, 27, and 30. Of course, there are more, but since m can only be from, and also 33, and since m can only be from 0 to 9, we can add, to get to 24 from 22, if 22 plus m is 24, m can be 2. If 22 plus m is 27, m can be 5. If 22 plus m is equal to 30, m can be 8. And for 33, if 22 plus m is 33, then m has to be 11. So this one would not work since m is now 2 digits. So the possible values of m would be 2, 5, and 8. Now we're going to take a look at the next example. So it says a 6-digit number begins with the digit 7. So we have 6 digits and it begins with 7. The number is divisible by 9, and that tells us that the sum of the digits must be divisible by 9. Then it says all 6 digits of the number are different. Find the smallest possible value of this number. So to make the 6-digit number the smallest, we know that the missing numbers must be comprised of small numbers like 0, 1, 2, and 3. And so, since all the numbers must be different, we're going to make, and we want the smallest possible value, we're going to fill in the blanks in order from 0, 1, 2, 3, because we want the 10,000 place, which is the largest option we have to change since 7 is fixed, and we want that to be the smallest. And then since the number has to be different, we're going to use the smallest possible values. And so it's going to be 7, 0, 1, 2, 3. And with that information, we're going to look for our last missing digit. So far the sum of the digits are going to be 13 plus a missing number m. And so 13 plus m must be divisible by 9. And so a multiple of 9 that's closest to 13 is going to be 18. And so that tells us that m must be equal to 5. And so the smallest possible value is going to be 701,235. Now let's take a look at one more example. And so it says, find the values represented by the missing blank in the 6-digit number 458,000 blank blank blank, such that the number is the smallest and is divisible by 3, 4, and 5. So divisible by 3 means that the sum of the digits is divisible by 3. And divisible by 4 tells us that the last 2 digits must be divisible by 4. And divisible by 5 tells us that the last digit is either 0 or 5. And so we have the numbers like this. But then, since for divisibility by 4, we're going to look at the last two digits, and divisibility by 5 tells us that the last digit has to be either 0 or 5. If the last digit is 5, then we know that when we look at the last two digits, it's never going to be divisible by 4. So we know that the last digit must be 0, right? Since if the last digit is 5, then when we look at the last two digits for 4, it's not going to be divisible by 4. And so the last digit must be 0. So that fulfills divisibility by 5 and allows us to check for divisibility by 4 now. And so we want the smallest number that's divisible by 4 and 5, as well as 3. And so we know that the tens place should be 0, because 0, 0 is basically 0, so we know that that's divisible by 4, and the smallest tens place is going to give us it's going to help us find the smallest possible value. So we know that the last two digits should be 0, 0, and that fulfills the requirements for divisibility by 4 and divisibility by 5. So now all we have to consider is divisibility by 3, and so 4 plus 5 plus 8 plus the missing number m plus 0 must be divisible by 3. And so that is going to be 17 plus m. And a multiple of 3 that is the closest to 17 should be 18. And so m must be 1. And so our number is going to be 458,100. Now we're going to solve some practice problems. And so we're only going to solve a few problems because we have a lot of problems to go through. And so it says, check whether the following numbers are divisible by 3 and by 9. So we're going to add this digits together to find the sum of the digits. And that is going to be 18. So 18 is divisible by both 3 and 9. So the number is divisible by both 3 and 9. For 10,002, when we add the digits, we get 3. So 3 is divisible by 3, but it's not divisible by 9. So we're going to say that the number is divisible by 3 only, not 9. Then if we have 18,135, we're going to get the sum of the digits. We'll solve C as well. And the sum of the digits is going to be 18, so it's divisible by both 3 and 9. And then the next problem says, if a number is given as 1,234, its palindromic number is 4,321. So we just switched we switched from the very end to the very beginning. So that's our palindromic number. And is 5,154 divisible by 3? And how about its palindromic number, 4,515? So basically, if we're checking for divisibility by 3, then we only have to consider the sum of the digits. So regardless of the order of the number, we're only looking for the sum. And since the numbers are comprised of the same numbers, 2 5s, 1 1, and 1 4, the sum is going to be the same for 4,515 and 5,154. And so when we add the digits together, it's going to be 15. So it is divisible by 3, so both numbers are divisible by 3. And then the next problem says, if a number is not divisible by 10, can it still be divided by 5? So divisibility by 10 is that the last digit is 0. For divisibility by 5, the last digit is either 0, or 5. So if the last digit is 5, it would not be divisible by 10, but still be divisible by 5. So yes, if a number is not divisible by 10, it can still be divided by 5. But then the next question says, if a number is not divisible by 5, can it be divided by 10? So divisibility by 5 says that the last digit is either 0 or 5. Divisibility by 10 states that the last digit must be 0. But if it's not divisible by 5, then it means that the last digit is not 0 or 5. And since the last digit is not 0, it must not be divisible by 10. So if a number is not divisible by 5, it's not divisible by 10. Now we're going to check for divisibility by 7 and by 13. So we're only going to look at A and B. So for A, for divisibility by 7 and by 13, the rule was that we look at the last two digits and then look at we look at the last three digits and look at the preceding digits. So the last three is going to be 041, which is 41, and the preceding number is going to be 15. So the difference between 41 and 15 is going to be 26. Now 26 is not divisible by 7, but it is divisible by 13 because 26 divided by 13 is 2. So 15,041 is divisible by 13, but not 7. For the number 397,523, the last three digits are going to be 523, and the preceding digit is 397, so the difference is going to be 226. Now 226 is divisible by 7 because 226 divided by 7 gives us I'm sorry, the calculation was 126. I'm sorry for the confusion. So it's divisible by 7 because 126 divided by 7 is going to be, it's going to be 18. But then when we try to divide it by 13, it's not divisible by 13. So we're going to say not divisible by 13. And so for the number 397,523, it's divisible by 7, but not 13. And so this is a similar question to what we did, but we're checking for divisibility by 9 and by 11. For 9, we're basically looking at the sum. So for a palindromic number, and also a palindromic number is a number that reads the same forward and backward. So the sum is going to be, sum of the digits is going to be 37. And 37 is not divisible by 9. So that tells us that the number is not divisible by 9. But for 11, we're going to calculate the sum of the even digits of the even place and digits of the odd place. So some of the digits of the even place are going to be 5 plus 7 plus 5. Which is equal to 17, and the sum of the digits of the odd place is going to be 4 plus 6 plus 4 plus 6 plus, I'll just do it in blue, 4 plus 6 plus 6 plus 4, that's going to be 20, and so the difference is going to be 20 minus 17, which is 3. And 3 is not 0, and it's also not a multiple of 11. So this number is not divisible by 9 or 11. So for divisibility by 11, again, we just reviewed that we look for the sum of the even digits of the even place and digits of the odd place and look for the difference. And if the difference is 0 or either a multiple of 11, then that would be divisible by 11. So you guys can try these problems on your own. And we're going to review this last question. So we're testing for divisibility by 13. And for divisibility by 13, we're going to look at the last 3 digits and the preceding number. And so the last 3 digits is going to be 645. The last 3 digits are 645, and the preceding digits are 3,466. And so the difference is going to be, the difference is 2,821. And so we're going to see after we got 2,821, if we go back to what the divisibility rule for 13 was, it says we're looking for whether the number can be divided by 7 or 13. And so now we have 2,821, and we can just test whether this number itself is divisible by 13 or not, by doing division. And that is going to be divisible. But another way to do this is, even though we got 2,821, it's still quite big for us. So we're going to take that step again and see if that number is divisible by 13 or not. And so to do that, we add the last 3 digits, 821, compare the difference with the preceding digit 2. So that's going to be 819. And so now we're going to see if 819 is divisible by 13. And so that makes our step much easier. So we get 63, so we know that it's divisible by 13. And so since 819 is divisible by 13, that tells us that 2,821 is divisible by 13. So that ultimately tells us that this number is divisible by 13. And that was it for our lesson today, and I'll see you guys in the next video.